A good day to all of you. So I'm Sudikin sir here. I'll be solving the class 10 ICSE physics final paper of 2023. And I've seen the paper. According to me, the quality of paper is a little bit higher than medium. It's better that you see the solutions here and verify with those that you have done. So whether you have done good or you have done moderate or whatever you have done, don't think more about it. Focus on your next exams because they're important. And physics covers only 33% of the science portion. So if you do bad in physics, that doesn't mean that you have done extremely bad, because the other two subjects, chemistry and biology, are there. If you do good in those, your average score will be better. Okay, I won't talk much, but I'll be starting the solution from section A. So let us start from section A and 1 1. So what is it saying? Clockwise moment produced by a force about fulcrum is considered to be clockwise moment. Now we know there are two kinds of moment. Okay, one is the clockwise moment, which is in the direction of clock. This is 12, this is 3, this is 6, this is 9. So this is the clockwise moment. And another one is the anti-clockwise movement, which is in the opposite direction of clock. So if it is 12 3 6, that is in the opposite direction of clock. So this we call as anti-clockwise movement. And this anti-clockwise movement is always taken as positive. The clockwise movement is always taken as negative. Okay, so the answer here will be clockwise movement produced by a force about a fulcrum is considered to be is considered to be negative. Okay, is considered to be negative. This is negative. Okay, next question states, when the speed of a moving object is doubled, there is kinetic energy. Okay, number 2, they are saying that if the speed is double, that is the velocity v2 will be twice of v1. Okay, now we know kinetic energy is given as half m1 v1 square, this ke1, and ke2 is given as half m2 v2 square. Okay, now if we do a ratio of both of them, that is ke2 by ke1, we get m2 v2 square by m1 v1 square. Now they have said nothing about mass, that means mass remains the same. So if mass is same, then m2 will be equals to m1, and then ke2 by ke1 will be v2 by v1 and its square. So v2 is double of v1, that is 2v1 by v1, so that will be 4, or ke2 will be 4 times of ke1. So kinetic energy will become 4 times. Now the next question, the energy conversion in a washing machine is from. So washing machine, now what do we do in a washing machine? What do we do in a washing machine? In a washing machine, suppose this is a washing machine, so we give electrical energy here. Okay, and we get to wash our clothes. Okay, and it rotates, that means the electrical energy gets converted to mechanical energy. So this is mechanical energy. Let us see, electrical to mechanical, so B is the right answer. Now let us go to option 4. Okay, which of the following radiations after maximum deflection or suffer maximum deflection in a magnetic field? Okay, maximum deflection they are saying. Okay, remember deflection depends on charge by mass ratio. Okay, if the Q by M ratio is more, then deflection will be more. If the Q by M ratio is less, the deflection will be less. Now the particles given here are alpha, beta, gamma and X-ray. See, this is electromagnetic wave, this is electromagnetic wave, like light. Okay, as their electromagnetic wave. Now electromagnetic wave does not suffer any deflection, so no deflection will occur for them. Deflection will go for alpha and beta, but the charge by mass ratio of beta is much greater than the charge by mass ratio of alpha. Okay, so the beta will get deflected more. So if we see it as radiation coming out from a sample, and if the deflection occurs, then more deflection will occur for beta, less for alpha if we consider it as a negative plate and this as a positive plate. Okay, so here the answer will be beta radiations. Okay, next, speed of blue light in water is more than green light, more than orange light, more than violet light, more than red light. Okay, it's a good conceptual question. Okay, it's a good question. See, let us draw VIBGYOR. Let us draw VIBGYOR. Okay, now when a white light falls on the surface separating and water air and water, what happens is that the white light splits into its constituent colors. Okay, the maximum deflection occurs for violet, the minimum deflection occurs for red. That means refractive index, that is mu of violet, is greater than mu of red. Now if I write VIBGYOR here, more we shift towards the red, that is more we shift in this direction, lesser will be the refractive index. Now here they are saying about blue light, so this one is blue light. Okay, now from here we can see the refractive index of blue light is greater than these G, Y, O and R, and the refractive index of blue light is less than V and I. Now let us see which one matches here. It is more than green light, this is true. It is more than orange light. Okay, this is also true. Oh, they're saying speed. Okay. Wait. They're not asking about refractive index. They're asking about speed. Now, if we look at speed, more the refractive index, lesser the speed. Okay, that means in order of speed, the conditions will change. Okay, in order of speed, this V and I has more diffractive index, that means lesser speed, and GYOR has less refractive index, that means they have more speed. That means B will, that is blue, will be having speed lesser than GYOR and greater than V and I. So now let us see what are the options here. So more than green light, no, it will be less than green. More than orange, no, it will be less than orange. More than violet, yeah, this one is right, more than violet. More than red, no, it will be less than red. Okay, just compare your answer with this situation. Okay, so if I write it in short, I will write it in this way, that B will have velocity, greater than greater than V and I, lesser than GYOR. Okay, so it's a bit, I would say it's a medium level question. It's a medium level question. Okay, this one was a easy question, I would say. This one was also a easy question. This one was also, I would not say easy, because this type of question generally doesn't come. I will give it E plus, like a bit higher than easy. This one is on Q by M. This one is also a bit higher than easy. Okay, now let us go into question number 6. Question number 6, what does it say? A concave lens produces dash image. Now concave lens, this is a concave lens. Okay, the only kind of image that we get in a concave lens is on this side. So this will be first property virtual, then it will be erect, and then it will be diminished. Okay, it will be diminished. Like I should have drawn it a little less. It will be diminished. So these are the three properties of this image. So let us see here: virtual, real and enlarged. No, this is not possible. Virtual and enlarged, no, that is only possible in case of convex lens. Virtual and diminished, yeah, this one is possible. This is also an easy question. Okay, when a body vibrates under a periodic force, the vibration of the body are always, when a body vibrates under a periodic force. Okay, so that means we are giving an external force. So if we give an external force, then the condition of forced vibration comes into play. Now it is not always necessary that forced vibration means resonance. So if someone thinks that if a body vibrates under periodic force it will be resonance, then that may be a wrong answer. Okay, it will be under forced vibration. So that will be under forced vibration, not resonance. Resonance is a special case when the frequency or the original frequency of the body matches with that of the forced vibration. In this case, it's not happening. Okay. Now let us go to question number 8. Okay, what does it say? Two notes are produced from two different musical instruments such that they have same loudness and same pitch. Two different musical instruments, they have same loudness, same pitch. The produced notes different. Two notes are produced from two different musical instruments, same loudness, same pitch. Okay, see, there are two factors they have discussed. One is discussed, that is, one is loudness, another one is pitch. Now loudness is dependent on amplitude, pitch is dependent on frequency. Okay, that means they have same amplitude, same frequency. Then what is different? Two notes are produced, then the quality is different. Quality is different, that means quality is different. Quality depends on waveform, so that means their waveform is different. Okay, let me draw two waves. This is the first wave, this is the second wave. So they are saying that it has same frequency and same amplitude. That means if it also has this amplitude, this one is also having this amplitude. But suppose this wave looks like this one and this wave looks like this one. This wave looks like, just wait, this wave looks like this one. See, they are not same, they are having different waveform, or you can say it may look like this one. So they are having same amplitude. Okay, they are having same amplitude, but their waveforms are different. So the answer here will be waveform. Okay, next I'll go to 9. Question number 9. It's saying when a current I flows through a wire of resistance R for time t, electrical energy, it's easy, it's I square RT. So this one is easy. This one is also easy. Okay. This one is also easy. It's a bit tricky but easy. I will give it as E plus. Okay, because many of you may think of it, not this one, sorry. Many of you may think of it as resonance, so I'll give it a E plus. Okay, choose the correct relation for EMF and terminal voltage. Okay, see, we know that for a circuit, EMF equals to I into capital R plus small r, or if we expand that, then EMF will be equals to IR plus I small r. This one is the terminal voltage V, this one is the voltage drop small v, or lost voltage. That means epsilon equals to capital V plus small v. That means capital V will be epsilon minus small v. So it will always be less than the EMF. So we can say V is always less than epsilon. Okay, a capital V, sorry, let me make it clear. Capital V is always less than epsilon. Let us see it here. So capital V greater than epsilon, this is not possible always, because if the internal resistance is 0, only in that case this one is possible. Okay, this is possible only when R equals to 0, where R stands for internal resistance. Or V greater than capital V greater than epsilon, no, it's absolutely wrong. So V less than epsilon when the cell is in use. Yeah, this one is a good answer, when the cell is in use. Now epsilon equals to V is also possible in the case when the cell is not in use. Okay, that is also possible in this case, but generally we don't do it in that way. So the answer will be C. Okay, let us go to 11. If the strength of the current flowing through a wire is increased, the strength of the magnetic field produced by it. Okay, so this is a wire. Okay, now they are saying the strength of the current flowing through a wire is increased. So if the current strength is increased, the magnetic field strength will obviously increase. So it will increase. Okay, next, specific latent heat of a substance. Okay, specific latent heat of a substance is directly proportional. What is specific latent heat? Let me show you. We know that heat Q equals to mc delta T. Okay, here this C is specific latent heat. Okay, this one is specific latent heat. Now they're saying specific latent heat of a substance is directly proportional to mass. No, is directly proportional to the change in temperature. Depends on the material, is inversely proportional to the mass. See, specific latent heat is a material dependent property. Okay. Now, the value of C is fixed. How is it fixed? Suppose for water, the value of C is 4200 joule per kg per degree centigrade. Okay, so that means it is fixed for a substance. Now, from here we can say that this one does not have any depending factors. Okay, that means whether the temperature changes or the mass changes or the heat changes, it won't affect the specific latent heat because this is a constant value. This is a constant value and it is material dependent. This is material dependent. Okay, so it depends on material. Now, specific heat capacity of substance X is 1900 joule per kg per degree centigrade. Okay, means substance X absorbs 1900 joule for 1 degree rise in temperature. No, per kg. They have not written per kg, so this is not possible. 1 kg of substance, now it's coming good. 1 kg of substance X absorbs 1900 heat for 1 degree rise in temperature. Okay, this one seems good. 1 kg of substance X absorbs 1900 joule heat to increase the temperature. No, they have not told how much they are increasing the temperature. This one is also not right. 1 kg of substance X absorbs 1900 to cool down by 1 degree centigrade temperature. Okay, okay. Now this one also seems right. Okay, now the trick is when you absorb heat, you never cool down. It's a good question. I will rate it as a medium level question. Okay, because when you absorb heat, you don't cool down. If you lose heat, then only you cool down. Okay, it's a good quality question. Good quality question. Okay, so this won't be the answer. The answer will be B. Okay, remember, because if you absorb heat, you don't cool down. So because of that, this one is wrong. So it's a good question. Okay, now let us go to question number 15. Go to question number 15. Okay, when a ray of light travels normal to the given surface, then the angle of refraction is. Okay, a ray of light travels normal to a given surface. Suppose this is a given surface. Okay, now they're asking about refraction. Now let us take this one as air and this one as glass. Now this is the surface. Now what does normal to a surface mean? Normal to a surface means it is traveling like this. This is normal to a surface. Okay, now when it is normal to a surface, the angle of incidence I is 0 degree. That means obviously the angle of refraction will also be 0 degree. That means it will pass straight away into the medium. So the angle of refraction will be 0 degree. This is the answer. It's an easy question. Okay, it's not a tough question. Okay, small air bubbles rising up a fish tank appear silvery when viewed from some particular angle is due. Now this is a good question. I will rate it as a medium level question. Okay, let us get into this question. It is saying that small bubbles rising up a fish tank. Now let us draw a fish tank and let us draw a small bubble. So let this be the small bubble. Okay, now it appears silvery from some particular, you have to listen to it properly. It appears silvery from some particular angle. Suppose a ray of light is coming here. Okay, now suppose the ray of light falls at an angle which is greater than the critical angle, which is greater than the critical angle. Then what will happen? Total internal reflection. In that case, this ray of light will pass like this and it will enter the eye of an observer. Now what he will see? He will see that it is appearing like a mirror, which means it will appear silvery. So this answer will be the case of a total internal reflection. Okay, it's a good question. Many of you may give the answer as dispersion, but dispersion is possible for a water droplet. Remember, when this light is coming in, the medium, this medium, the outside medium is denser, okay, and the inside medium, inside the bubble, this medium is, this is rarer because it has air in it, okay, and this is denser because it has water in it. You should keep this in mind, okay. It's a good question. Chalo. So we have completed the section A, question number 1 portion. Now we will go to question number 2 portion. Let us go to question 2. Question 2. Just hold on. Chalo. আবার শুরু করা যাক. Okay, let's start again. Okay, I'm a Bengali, that's why I have to sometimes speak in Bengali. Okay, so I'm mother tongue, na? Okay. Question 2, we'll get into question 2. It says, when does the nucleus of an atom tend to become radioactive? Okay, nucleus of an atom tend to become radioactive when the neutron by proton ratio becomes greater than 1. More specifically, when it becomes greater than 1.5, it's specially radioactive. But for any case greater than 1, for the n by p, there is a chance that it will be more radioactive. Okay, this is the answer. Next, name a single pulley in which displacement of load and effort is not same. You have done that already. You have already done that, and that will be for a single movable pulley. If we draw a single movable pulley, okay, if you draw a single movable pulley, and if this be the load and this one is the effort, so if you move the effort distance two times, if you move the effort distance, then the load distance will move 1 times. Okay, if the distance of effort is 2 times, the distance of load will be 1 of that distance. Okay, suppose you move this one by 20 centimeter, this one will go up by 10 centimeter. So this is your answer. Okay, now let us get into the next question, that is C, which states, state one advantage of this pulley. Now this pulley has mechanical advantage greater than 1. So whenever you have a pulley with a mechanical advantage greater than 1, you can use it as a force multiplier. So we can use this one as a force multiplier. Okay, this can be used as a force multiplier. Okay, to option A. What is the position of center of gravity for a triangular lamina? Okay, for a triangular lamina, if I take a triangular lamina ABC, and if I draw the medians, then if the median is O, then the center of gravity will lie at the point of intersection of the medians. Okay, so it will lie at the point of intersection of the medians. Okay, question number 2b, it's saying, when this triangular lamina is suspended freely from any one vertex, what is the moment of force produced by its own weight in its respective? Now how we get the center of gravity for any arbitrary lamina? Suppose this is an arbitrary lamina, and let this point be A, this one be B, this one be C. Now if I suspend from point A the lamina, then if I put a plumb line, then the plumb line will be straight in some ways. Okay, now the center of gravity will lie somewhere on this plumb line. That means if you do the same thing by rotating and putting the various vertices, then you will be getting various plumb lines. Like this will be the plumb line of B, this one will be the plumb line of C. Okay, now where the plumb line intersects, these are the plumb lines, where the plumb lines intersect this position, it acts as the center of gravity. Now if you suspend it from one vertex, then the center of gravity will be lying on that plumb line only. That means the net moment about this plumb line will always be zero, because the center of gravity will lie on that plumb line only. So in this case, what is the moment of force produced by its own weight? The total moment of force will be zero. Okay, so the answer will be the total moment of force. The total moment of force will be zero as, let me write it as zero, as the center of gravity will lie on the plumb line. Okay, this one is your answer. So that is B, 2, option B. Okay, and number 3, the question number 3 is, the diagram shows wheel O pivoted at a point A. Okay, so this one is our wheel O pivoted at a point A. Okay, so this is the pivot. Okay, wheel O pivot at a point. Okay, this is the pivot. That means it will be able to rotate about this point, not about this point. Okay, okay, it's a good question then. 3 equal forces F1, F2 and F3 act at point B of the wheel. Okay, which force will produce maximum moment about A? Acha. See, it only depends if you have the forces F1 equals to F2 equals to F3. If they are not same, then we cannot do this answer. Okay. Now, if we consider them as same, then if we draw a line from A, like this, and if we extend the portions, like this one is the, like we can do this one. Okay, okay, let me do it in another way, then it will be easier for you. Okay, let me draw it here, then that will be best. Okay, so this one is my wheel, and this is the pivot A. See, it's not here, it's here. Okay, this was it, is it center or whatever, I'm not interested in that. Now if I consider the action of three forces separately, look at it carefully. If I consider the action of three forces separately, then what I will get? Suppose I consider all of the forces as having same magnitude, that is value of F1 equals to F2 equals to F3. I'm considering it in this way, otherwise it won't be possible. So F1 is here in this direction. Okay, now I will draw a perpendicular on this F1. So if I draw a perpendicular, and this one is F1, I'm coming to it later on. Now next I'm having a force F2, so let me draw a force F2 at this point. So this one is F2. I will extend the F2 like this. I will extend the F2 and I will draw a perpendicular on F2. Okay, and next the case is of F3. Now F3 is like this. F3 is like this. Let me do it. F3 is like this. Okay, this one is F3. Now again I will extend F3. I will extend F3 and I will draw a perpendicular on F3. Now if I look at the three cases, if I give this distance as D3, this one as D2, this one as D1, and I consider all the forces same, then it is obviously D1 greater than D2 greater than D3. That means moment produced by force 1 will be greater than moment produced by force 2 will be greater than moments produced by force 3. So in this case, which force will produce maximum moment about it? That will be, according to me, if I consider the forces same, then that will be F1. So the answer is F1. Okay, for me this is a pretty good question. Okay, and you can give the reason also. It's a pretty good question. I will mark the level of hardness for this question as easy. This one is also easy, this one is also easy. Position center gravity triangle, this one is easy. This one will be medium. Okay, this one I will say will be medium plus. Yeah, it's a good question. Okay, let us go into question 4. Question 4. Okay, what should be the angle between the direction of force and the direction of displacement for work to be negative? This is also a good question. Okay, most of you will write it as 180 degree, but that's not the answer. See, suppose this is a block, you apply, suppose the block is constrained to move in this forward direction. Okay, so its displacement whatever will be in this direction. Now if I apply a force, okay, which is in the direction, which is in the direction of the block, that means if I apply a force in this direction, then obviously it will be positive. Now if I apply a force in this direction, this is acute angle, work done will be positive. If I apply it in this direction, this is also acute angle, this is also acute angle, then also it will be positive. But if I apply it here, then this will be 90 degree. In that case the work done will be 0. So for any value less than 90 degree, that is for any acute angle, work done is positive. Now if I give the force perpendicular to the direction of motion of the body, then that is 90 degree, then in that case work done will be 0. Now if I give a force, now understand it properly, okay, now if I give a force in this direction, that will be negative work. Okay, now this is not 180 degree, this is obtuse angle. If I give a force in this direction, that is also obtuse angle. If I give a force in this direction, that is also obtuse angle. Okay, if I give a force in this direction, that is also angle greater than 180 degree but less than 273 degree. So the proper answer for this will be, if you write it as obtuse angle, you will get marks. If you write it as 180 degree, then also you can get marks. But the proper answer is from the angle made if taken as theta, then theta will be greater than 90 degree and less than 270 degree. This is your actual answer. Okay, so this one is actually a hard question, this one is actually a hard question, but depending on your answer you can also get number in the following cases. Okay, the invigilator can give you number in this cases, so don't worry if you have written these also, these are also right, it's not completely wrong, you will get the numbers. Okay, now we go to B. Name the physical quantity obtained using the formula U by H, where U is the potential energy, H is the height. Acha, potential energy U we know equals mgh. Now if I divide U by H, then that will be mgh by H, so that will be mg. Mg stands for force. So what is the physical quantity? This one is the force. This is easy question. The physical quantity is force. Okay, let's go to question number 5. uh Calculate the power spent by a crane while lifting a load of mass এত kg at velocity. Okay, we know power equals to F into V, right? Or F according to here has a mass mg into V, we can write m is 2000, g is 1 point, g is 10, and V is 1.5. So we will be 1.5 times 2000, that will be 15 times 200, so that will be 3000 times 10, that will be 30,000, or the answer will be 30,000 watt. Okay, if you write it as 30 kilowatt, this will also be right. Acha, so you got that one. Okay, next, question number 6. So this one is easy, pretty easy question. Question number 6. Question number 6. A metal foot ruler is held at the edge of a table. What metal foot ruler? Okay, a metal foot ruler may be a ruler which is used for measuring the length of a human feet for buying, I think, shoes. Okay, let us see. It is pressed at its free end and then released. Oh no, no, metal foot ruler is, sorry, metal foot ruler is 1 foot ruler made up of metal. Okay, so what is a metal foot ruler? That is not that. Metal foot ruler equals to a ruler made up of metal and length 1 foot. Okay, so this is the table. A metal foot ruler is kept on the edge of a table. Good. It is pressed at its free end and then released. So it is pressed here and released. It vibrates, obviously. Okay, name the vibrations produced. Okay, state one way to increase the frequency of this vibration. Okay, name the vibrations produced. Okay, see, the vibrations that will be produced freely, because we will not be giving a constant force in them to sustain the vibration, because after some time it will stop vibrating. So if you write it as free vibration, free vibration, or if you write it as natural vibration, you will get the full marks. If someone writes the answer as a free vibration that will a free vibration that will eventually that will eventually that will eventually attenuate means to reduce in amplitude, attenuate due to damping, this will also be the right answer. Okay, both of them will be the right answer. Okay, name the vibration produced. So that is a free vibration, I would say. Now state one way to increase the frequency of vibration. Okay, how will you increase the frequency? We can increase the frequency of vibration by reducing the length of the ruler. Okay, so the portion that is suspended outside the freely suspended portion, if you reduce the length of the freely suspended portion, this frequency will increase. So the answer will be, answer B will be, if the length of the freely suspended portion, if the length of the freely suspended portion is decreased, its frequency will increase. Okay, okay, now let us go to 7. A geyser is rated 240 watt, 220 volt. Explain the meaning of this statement. Okay, the statement means that the maximum power that the geyser uses is 240 watt and the operating voltage of the geyser will be 220 volt. This is a pretty easy question. Okay, this is an easy one. Okay, this is also an easy one, but this one I would say is a easy plus one. Okay, you need to have some concepts on it. Okay, question 3. Let us get into question 3. Question 3. Okay, is it possible for a concave lens to form an image of size 2 times that of the object? Concave lens always produces diminished image. So it can produce image in fractions lesser than 1. Okay, what does diminished image mean? What does diminished image mean? Diminished image means that the image that will be produced will have magnification, the mod value of the magnification, that is the positive value of the magnification, from 0 to 1. Okay, this is diminished image. Magnified image, magnified image means the magnification of that image will be always greater than 1. Okay, that is a magnified image. So concave lens can never form a magnified image. So size 2 times means magnification 2 times means magnification equals 2, that will be greater than 1. So that is not possible for concave lens. Okay, so the answer will be no. What will happen to the focal length of the lens if a part of the lens is covered with opaque paper? Nothing will happen. Focal length focal length is not dependent on the amount of exposed area. Okay, so suppose you have this concave lens, and you are getting some image due to this lens here. Suppose the image is bright, like you are getting a brightness level like this one. Now if you cover the portion, if you cover a part of the lens with the opaque paper, suppose you cover this one with the opaque paper, then you can imagine that you don't have this part. Okay, in that case also the image will be formed here only, but in the second case the brightness will be less. Okay, the brightness will be less. Hello. Okay, two. Option A, which electrical component protects the electric circuit in case of excess current, that is fuse, which can also be used and which can also be used as a switch. Oh, then that will be MCB. That's a good question. Okay, this is the medium level question. See, I will divide this question into two parts. First part, which electrical component protects the electrical circuit in case of excess current. Now, fuse can protect the circuit and MCB can also protect the circuit. So in case of protection, I will say, in case of protection, both of them are applicable. Okay, but we know that fuse is not reusable. Once the wire burns, you need to bring a technician. He will open the fuse, change the wire, he will again plug it in, then your whole circuit will again come into action. Okay, but for the MCB, that's not the case. If you want to close a circuit, if you want to do the work of a switch, that means if you want to break the current in a circuit, then you have to open this switch. Okay, now what happens if you drop the MCB down, it will automatically disconnect the circuit, and it is reusable, so you can use it as a switch also. But fuse you cannot, because it's one time usable, then you have to replace it. Okay, so for using as a switch, I would say this one can be used as a switch also. Okay, but fuse cannot be used. So it's a very tricky question. Here the answer will be MCB. Okay, MCB stands for, we know, all of us know that it stands for miniature circuit breaker. Okay, then 2 part B. What will happen to the focal length of the lens if a part of the lens is covered with an, it's already done, sorry. 2 part B, name the wire to which this electrical component is connected in electrical. Always live wire, always live wire, we know the answer. Okay, always live wire. Okay, so now let us go to number 3. Okay, number 3, a copper conductor is placed over two stretched copper wires. Okay, whose ends are connected to a DC supply. Okay, this is the DC supply as shown in the diagram. Okay, what should be the magnetic poles at the points A and B lying on either side of the conductor to experience the force in the upward direction? Okay, name the law used to find the polarity. Okay, let us read the question again. A copper conductor is placed over two stretched copper wires. So these are the two stretched copper wire. So it's a battery. Okay, and suppose this is the copper wire which is connected here. So if this is the battery, then the electricity will flow in this direction. Okay, so the current is flowing in this direction. Okay, now what should be the magnetic poles at the point A and B? Okay, so if this point is A and this point is B, A and B, okay, okay, lying on either side of the conductor to experience the force in the upward direction. Okay, now we need to give this conductor a force in the upward direction. Okay, now we know there are two rules. Okay, now one is the left hand rule, another is the Fleming's right hand rule. Now left hand rule is the FBI, right hand rule is the MBI. Now M stands for motion of the conductor, B stands for magnetic field, I stands for current. So if I place it in the way that they have shown, I will be in the downward direction. Now motion of the conductor, we know it to go in the upward direction, that is out of the paper. So I will be in the downward direction and motion will be in the out of the plane position. So this will be the direction of the magnetic field, that is MBI. So magnetic field will be directed along this way. This will be the direction of magnetic field. Now the question is, what should the magnetic poles at the points A and B lying on either side? Now we know if this is a north pole and this is a south pole, the magnetic field will go from north to south. Okay, so B will represent a north pole, A will represent a south pole. That's a very good question, I must say. Name the law used to find these polarities. That is Fleming's right hand rule. We will say it as Fleming's right hand rule. Okay, it's a pretty good question. I will mark it as a hard one. This is a hard one. Okay, and this one is an easy one. 3A is a hard one. Yeah, it's hard one. Okay, chalo, let us do number 4. Number 4. Thermal capacity of substance A or B and same. If A is of mass more than B, then which substance will have more specific heat capacity? See, thermal capacities are same. So C, capital CA equals to capital CB. We know thermal capacity, we write in capital. This is thermal capacity. Acha, by definition, what is thermal capacity? If we say heat equals to C into delta T, then this is thermal capacity, this is change in temperature, this is heat absorbed. Or we can write Q as MC delta T. In this case, this will be specific heat capacity. This is specific heat capacity. Okay, this is mass, this is change in temperature. So this one is thermal capacity, this one is specific heat capacity. Now in the question they are saying that thermal capacity of A and B are same, that is CA equals to CB. Okay, if mass of A is more than, okay, let us write it in terms of specific heat capacity. So we can say mass of A into specific heat capacity of A equals to mass of B into specific heat capacity of B. Or if we do the ratio, that is CA by CB will be MB by MA. Now according to the question, mass of A is more than that of B, that is MB by MA less than 1. Or CA by CB will be less than 1, or CA will be less than CB. That means which will have more specific heat capacity? The answer will be B. B will have more specific heat capacity. Okay, which substance will show greater rise in temperature if the same amount of heat is supplied to both? See, their heat capacities are same. Okay, that means you can write Q as CA delta T, that is QA, and you can write QB as CB delta T. If you do a ratio, that is QA by QB, you can write CA by CB into delta T by delta T. As the temperature, they are saying they are giving same rise in temperature, so delta T will be same for both. Now they have also said that the thermal capacities of A and B are same, that means C and CB are same, so these will also cut out. Then QA by QB will be equals to 1, or in that case QA will be equal to QB. This is your answer. Okay, so that means which substance will show greater rise in temperature? Sorry, I've done it the other way. Sorry, they have not said the temperature is same, they have said the heat given is same. Sorry, so that will be delta TA, this one will be delta TB. So if QA and QB are same, if QA and QB are same, then we can say QA and QB same, then you can write it as Q, so it will cut out, or 1 equals to delta TA by delta TB. So the answer will be delta TA equals to delta, that is both of them will have the same rise in temperature. Okay, so which substance will show greater rise in temperature if the same amount of heat is supplied to both? Both of them will show same rise in temperature. No one will be having a temperature difference more. Okay, this one I will say it's a easy plus question. Okay, a little bit higher than easy. Okay, number 5. How is the radioactivity of a radioisotope affected if it undergoes a chemical change? There is no change in radioactivity if there is a chemical change. Chemical change does not affect any nuclear phenomena, so there will be no change. Okay, the reason is chemical change does not affect the nuclear phenomena. Okay, chemical change involves only the change in the amount of electron or the way the electron is shared. That's the same thing, but it does not depend on the constituent of the nucleus, that is the neutron and proton composition. Okay, it doesn't depend on that. So we have completed section A. Now let us do section B. Section B. Okay, section B, question 4. The diagram below shows the ray OP traveling through an equilateral prism of a certain material. Calculate the value of I2 if the angle of deviation is 43 degree. Now they are saying that the angle of deviation is 43 degree. Okay. Okay, we know delta equals to I1 plus I2 minus A. Okay. Or we need to find I2. So we can write I2 equals to delta plus A minus I1. Delta is 43 degree. A is 60 degree, as they have said that it's equilateral prism, so that will be 60 degree, and minus of I1. I1 is 65 degree. Okay, see, this one is I1 because it is made with the normal, so the answer will be minus 5, and this will be, that is 38 degree. So that is the answer. Okay. Okay, what is the ray QA is called? QA is the emergent ray. This one is the emergent ray. So the next answer B, that will be emergent ray. Okay. Okay, next they are saying copy the diagram below and complete the path of the light ray PQ as it emerges out of the prism by making necessary angles. Okay, let us draw the triangle first. So this is our triangle. Now they have said that it is coming at an angle 90 degree. Okay, so when it will come at an angle 90 degree, it will straight away fall here. So this is 90, this is 60 as already given, then this angle will be 30 degree. So if we draw a normal here, this will be 60 degree. Now critical angle, they have said it is 42 degree. That means 60 degree is greater than 42 degree. So total internal reflection will happen. So in that case, it will go in this direction. So that is 60 degree. This one again will be 30 degree. As they have already said, this is 60. So this angle will be 90 degree. If it falls at 90 degree, then the angle of incidence on this plane is 0 degree. So it will straight away go like this. Okay. It's easy question. This one is also a easy question. Okay. Okay. Number 3. Number 3. The diagram below shows two parallel rays, A for orange, B for blue, incident from air on air glass boundary. Okay. Copy and complete the path of rays A and B. So this is the ray A, this is the ray B. Okay. So they are saying A is orange, so let us draw it by orange. And they are saying B is blue, so let us draw B by blue. Okay. This is B, this one is A. Now copy and complete the path of rays. So we know that previously we have already done. If we draw this one, then in this order the refractive index will increase. That is, the refractive index for orange will be less than that of blue, because mu blue is towards the left, so mu blue will be greater than mu orange. So more the refractive index, greater will be the deviation, so more will be the bending. That means the blue ray will emerge out in this direction or refract in this direction. The orange ray won't do that, it will have less deviation. Okay. Okay, how do the speed of this rays differ in glass? As already said, more the refractive index, lesser is the speed. That means speed of blue will be less than speed of orange. So How will the speed differ? The blue will have a lesser speed. Are the two refracted rays in glass parallel? Give it as no, they are not parallel because their angle of refractions won't be same as the refractive indices are not same. Okay. You can write it in this way. Suppose you can do it mathematically also, though it is not required. I won't recommend you doing this one, but you can do it mathematically also. Like if you take it as I, as they are parallel, this one is also I. Now this refractive angle of refraction will be RA. Let me write it as R orange and let me write it as R blue. Okay. Now we know from Snell's law, sine I by sine R orange will be mu of orange, and sine I by sine R of blue will be mu of blue. If we divide both of them, we get sine R blue by sine R orange will be mu orange by mu blue. Now we know that mu blue is greater than mu orange, so mu orange by mu blue will be less than 1. That is sine R blue will be say less than sine R orange. Or we know when the angle increases, the sine will also increase. That means the R blue will be less than R orange. Okay, so as we are seeing, R orange is more, R blue is less. So you can say that as both of the angles of refraction are not same, they will not pass out parallel to each other. You can say it in this way: as both of the angle of refraction are not same, they won't be parallel. They won't be parallel. Okay, so this one will be an answer. Just hold on for some time. I will say this one as easy, this one is also easy, this one is also easy. The section 4 is a pretty easy section. Okay, I think most of you have tried this one and most of you will be getting full marks in this section. I hope so. Okay, just hold. Okay, let us start from question 5. Question 5. Okay, a convex lens of focal length 10 centimeter is placed at a distance of 60 centimeter from a screen. So this is a convex lens. So there is a screen means always there will be real image. Okay, so this distance is 60 centimeter and the focal length is 10 centimeter. How far from the lens should an object be placed so as to obtain a real image on the screen? So they are saying we have to find out the object distance u. So see, the real image is formed. That means v is plus 60, and as it is a convex lens, so the focal length will also be plus 10 centimeter. We know the formula: 1 by v minus 1 by u equals 1 by f, or 1 by u will be 1 by v minus 1 by f. So in that case, 1 by v, that is 1 by 60 minus 1 by f is 1 by 10. So if we do the LCM, that will be 10 minus 60 by 600. So that will be minus 50 by 600. So 512 is 60, or u will be minus 12 centimeter. This one is the answer. Okay. So how far from the lens should an object be placed so as to obtain a real image? That will be 12 centimeter in front of the convex lens. Let us do number 2. Okay, 2 option A. A coin is kept inside water when viewed from air in a vertical direction appears to be raised by 3 millimeter. Okay, fine. So this is the water and a coin is placed here. This is the layer of water. Now a person is viewing the water from up. So this is the real depth and the water appears at some raised level. So this one is the apparent depth. So this one, real depth minus apparent depth, this is the shift. According to the question, shift is given as 3 millimeter, that is 3 into 10 to the power minus 3 meter. Now find the depth of the coin in water. So they are asking of the real depth. So we know we have a formula: shift equals to real depth into 1 minus 1 by mu. Okay, or real depth will be shift divide by 1 minus 1 by mu. Now shift is 3 millimeter, that is 3 into 10 to the power minus 3 meter, divided by 1 minus 1 by mu is 4 by 3, so that will be 3 by 4. So 3 into 10 to the power minus 3 by 4 minus 3 into 4. So that is 3 4 is 12 into 10 to the power minus 3 meter, or the answer can also be written as 12 millimeter. Okay, so what is the depth of the coin in water? That is 12 millimeter. Okay, how is the critical angle related to the diffractive index of a medium? 2b. Suppose this is a denser medium, this is a rarer medium. Okay, critical angle is always found out when the angle in the denser medium is critical angle such that the angle in the rarer medium is 90 degree. So if we apply Snell's law here, we can write it as sine r into, suppose this is mu rarer, mu r equals to sine ic into mu denser. Or we need to find out critical angle, so sine ic equals to mu r by mu d by sine r. Okay, so mu r by mu d, that means 1 by mu into sine r, that is sine 90. Sine 90 is 1, so that will be 1 by mu, or sine ic equals to 1 by mu, or ic equals to sine inverse 1 by mu. This is your answer. Okay, so how is the critical angle related to the refractive index of a medium? So critical angle equals to sine inverse 1 by refractive index. This is your answer. Okay, this is a easy question, is very easy question. This one is also very easy question, this one is also very easy question. This is an easy portion. Okay, light questions that they have given from light, the portion they have given from light are easy. Okay, pretty easy. Okay, infrared radiations are used in warfare. Explain with reason. See, infrared radiations are actually heat radiations. Okay, now heat radiations can go farther distances. Moreover, if you use infrared radiations, they can detect the body temperatures. Okay, suppose this is the battlefield. I will explain it in this way. This is the battlefield. Okay, in the battlefield, suppose this is a human being in battlefield, and this is a plant. Now the body of the human being will be hot, so the infrared camera, it will not detect anything. It will detect that there is a bright spot. Suppose this is red, this is yellow, and the other places are blue or black. That means they are of low temperature. So if a person has to hit someone, he will only hit the hot target, then the human being will die. Okay, so in warfare we need to identify our opponents. That is why we need to have specially developed infrared cameras which can detect infrared radiations. So infrared waves are used in the warfare. Okay, okay, actually reason why we told you. And the infrared radiations are able to go over a larger distance, so detection over a larger distance is possible. Okay, next is B. A ray of light is incident at 45. This is easy question. Okay, ray of light is incident at 45 degree on an equilateral prism in the diagram below. Okay, this is the diagram. Name the phenomena exhibited by the ray of light when it enters and emerges out of the prism. Name the phenomena exhibited by the ray of light when it enters and emerges out of the prism. Okay, state the cause of the phenomenon. It's a tricky question. Okay, the first thing is refraction occurs at both of the surfaces. Okay, so if I write it in this way, I think it will be most appropriate. It's a tricky question. Okay, it's a tricky question. If I write it in this way, it will be most appropriate that if this is the prism, this is 60 degree, this one is 60 degree, and this one is 60 degree, and if the ray of light is coming like this and it is splitting into two parts, one is coming out as the red part, another one is coming out as the blue part. Okay, if it is splitting into two parts, we can observe two things. One is happening at this point, another one is happening at this point. Okay, let me mark it as a different color. Another one is happening at this point. Now for the yellow mark portion, I will say that dispersion has occurred here because the light has splitted, so dispersion must have happened there, because the white light has splitted into its constituent colors red and blue. Okay, but in the green portion there is no dispersion. Dispersion occurs only at the first surface. So in the green portion, what happened? In the green portion there is only refraction, no dispersion, but only refraction. In the first part, that is in the first surface, there is dispersion as well as refraction. Okay, both are occurring at the first surface, but in the second surface only refraction. So this is the phenomena. I will say it as a E plus question. Okay, it's a good question. Acha. Question 6. A block and tackle system of pulleys has velocity ratio 4. Okay, draw a label diagram of the system indicating clearly the direction. It's a pretty easy question. Velocity ratio 4 means there are only 4 pulleys. Okay, that means 2 pulleys will be at the block, 2 pulleys will be at the tackle. So let us draw the block first. So these are the block pulleys. We should start from the bottom. So this one, then we will have a bigger one here. Similarly, we will have the tackles as this one, tackles as this one, and we will be having bigger ones here. Okay, not so big as the upper one, but a little less. So how will the, now this one will be hanging from here. So if we draw a string, the string will go straight like this, then it will come here, from there it will go here, and from there will be a hook, it will get attached to the hook. Okay, effort is applied in this direction. Here we will be putting the load, so this one is the load, and if the effort is applied in this direction, then this will be the tension. So there will be 4 tension for the load and 1 tension for the effort. Okay, so this is your answer. You can draw it in a better way, I'm just showing you faster so that it doesn't take a lot of time. Okay, now what is the value of the mechanical advantage of the given pulley system if it is an ideal pulley? For ideal pulley, we know ma and vr. For ideal pulley, ma by vr equals 1. That means ma will be equal to vr. As vr equals to 4, then ma will also be equal to 4. So the mechanical advantage will be 4. It's an easy question. Okay, next is this question number 6, part 2. Okay, I will mark this question as easy. This is an easy question, this one is also easy question. Both of them are easy question. Okay, number 2. A meter scale of weight 50 gf can be balanced at 40 centimeter mark without any weight suspended on it. Okay, let me again read it again. A meter scale of weight 50 gf can be balanced at 40 centimeter mark without any weight suspended. Okay, let us draw the system. Okay, this seems to be a good question. We have to do it slowly. Okay, this is a meter scale. So 0 to 100 there are markings. This is 10, 20, 30, 40. So this is the 40th mark. Then we get here 50, 60, 70, 80, 90 and 100. Okay, so usually what happens is that for a uniform meter scale, okay, if we don't give any force, it must get balanced at the 50th centimeter mark, but here it is not happening in that way. So a meter scale of weight 50 gf can be balanced at 40 centimeter mark without any weight suspended on it. That means this is acting at it as its center of gravity. That means the weight of this portion, okay, the weight of this one, let me copy it. Okay, we will be doing it slowly because it is going to be an interesting question, I hope. So the thought here is this portion, the mass of this portion till 40 will be equal to the mass of this portion till 100. Okay, that is going to be the case. Now if I divide it in this way, 0, 10, 20 and 30, weight of this portion will act from 20, and if it is 50, 60, 70, 80, 90 and 100, okay, so if I divide it in this way, 40, 50, 60, 100, 90, 80, so that means in this case the weight will act from 70. So if I write the weight of this portion as W2 and this portion as W1, and this distance as 40 minus 20, that is 20, and this distance as 70 minus 40, that is 30, then the anti-clockwise moment tau anti will be W1 into 20, and tau clockwise will be W2 into 30. According to principle of moment, anti-clockwise moment will be equal to clockwise moment, or W1 into 20 will be equals to W2 into 30, or W1 by W2 will be 3 by 2. Okay, so they are in the ratio 3 is to 2. Now if 50 GF is mass of the ruler, then W1 will be 30 GF, that is weight of the ruler. W1 will be 30 GF and W2 will be 20 GF. Okay, okay, just wait, let me extend the page, just hold on. Okay, so I've extended the page. Let us come to the question again. So now what they are asking, okay, so we have found out the weight portions. Okay, now what they are saying is that if this ruler is cut at its center, then state which part, 0 to 50 centimeter or 50 to 100 centimeter of the ruler will weigh more than 25 GF. Okay, now the thing is that we have done the detailed calculation. Okay, so we have already done the detailed calculation, and from the calculation we have found out the portion of W1 and W2. So from the calculation we can say that, just hold, from the calculation we can say that W1 portion, that is the left side portion, now this much portion is 30 GF, this much portion is 20 GF. Okay, that means this much portion is already heavier, this is already heavier. So if we see from 0 to 50, the heavier portion falls in this part. That means, what does that mean? That means 0 to 50 will weigh more than 25 GF. That means 0 to 50, just hold on, my sister has come, will weigh more than 25 GF. Just wait. Okay, so we have got the first answer. Now what minimum weight placed on this meter rule can balance this ruler when it is pivoted at its center? But minimum weight placed on this meter rule can balance this ruler when it is pivoted at its center. Minimum weight, what is the minimum weight? Okay, now this is a very important question. Okay, so if this is a ruler, okay, if this is a ruler and this is the 50th mark, okay, they are saying that when it is pivot, this is 50th mark, so this is 50th mark. Now we have already W1 in this portion, we already had W2 in this portion. Okay, then if it would have been balanced around this, just wait. So if this is 40th centimeter mark, that means it is having its net moment 0 if we take 40th centimeter mark as the pivot. Okay, that means 40th centimeter mark will be its center of gravity. That means if we take the ruler and if we pick a point from where its whole weight will act, that will be the 40th centimeter mark. That means the mass of the ruler is acting from 40th centimeter mark. Now the question asked is what is the minimum weight? Now minimum weight must be placed at the maximum distance. So maximum distance is 100 centimeter. So minimum weight must be placed here. So that is the minimum weight, suppose W. Now if we see the distances, this is 50, because 100 minus 50 centimeter, that is 50 centimeter, and this is 50 minus 40, that is 10 centimeter. So the anti-clockwise moment will be mass of the ruler into 10 centimeter, clockwise movement will be weight into 100 centimeter. Okay, or according to principal moment, both of them will be same, that is weight into 100 centimeter will be mr into 10 centimeter, or weight will be mr into 10 by 100 centimeter will cut away. Now mass of the ruler they have said is 50 gf by 10, so that will be 5 gf. This is the answer. This is the minimum mass which can balance this ruler when it is pivoted at the center. Okay, so you have to write this answer in this way, that when you write it in this way, that when we put a mass of 5 gf at the 100 centimeter mark, then this ruler can be balanced with a minimum mass of 5 gf when it is pivoted or balanced at the 50th centimeter mark. This will be your answer. Okay, it's I would say it's this portion, this question is hard. Okay, I would say this one is hard, because it will be hard for you guys, because you have not done this kind of question in your practice sets also. It's pretty hard for you, yeah, I must say. Okay, only a few can do this one. I think for the rest of you it will be a little bit troublesome. Don't worry, there are other sections also, you could have tried that one. Okay, a car of mass 120 kg moving at a speed of 18 km per hour accelerates to attain a speed of 54 km per hour in 5 seconds. Okay, so mass of the car is 120 kg. Speed they have said, I will write it as V. So V1 equals to 18 km per hour. So that will be 18 into 5 by 18 meter per second. So that will be 5 meter per second. And V2, that is 54 kilometer per hour. So 54 kilometer per hour will be 54 into 5 by 18. This will be 3, 5 3 are 15 meter per second. Okay. Now, all this happens in 5 seconds. So, all this happens in 5 seconds. Okay. So, we know V, that is final velocity. We know U, which is the initial velocity. We know the time, that is 5 seconds. So, what can we find out from here? We can find out acceleration, that is V minus U by T. So that will be V2 minus V1 by 5, that is 15 minus 5 by 5, that will be 10 by 5, or 2 meter per second square. Okay, this is acceleration. We can find out the displacement, that is S equals to ut plus half at square, or U is 5, T is 5 plus half into 2 into 5 square. So 25 plus 25, that will be 50 meter. Now first question is, what is the work done? Work done is force into displacement. So force is m into a into displacement is s. Mass is 120 kg, acceleration is 2 meter per second square, displacement is 50 meter. 100, that is 12000 joule. This is the answer. B, they have asked what is the power. We know power is defined as work done by time, that is 12000 by time. Time is 5 seconds. Okay, so 120 by 5, that will be 24. So that will be 2400 watt. Okay, 2400 watt. It's an easy question. Let us go to question number 7. Question 7. Question 7.1a. Okay, which characteristic of sound is affected due to larger surface of school bell? That is loudness. Okay, it's easy. Loudness. B. Calculate the distance covered by ultrasonic wave having a velocity of 1.5 kilometer per second in 14 seconds. Oh. Now that's a good question. When it is received after deflection by the receiver of sonar, distance covered after. Okay. So in 14 seconds. Okay. Calculate the distance of the ultrasonic having a velocity of 1.5 kilometer in 14 seconds. Received after deflection by the. Okay. So the sound is going there, the ultrasonic wave after reflection is coming back. Okay, total time taken is 14 seconds. So we know velocity equals to 2d by time. Okay, because it is covering twice of the distance. If we take this distance as d, as they are saying that it is reflecting and coming back to the receiver. Okay, so distance will be v into t times 2. So velocity is 15 kilometer, 1.5 kilometer per second. That is 1.5 into 1000 meter per second. Time is 14 divided by 2. So it will require a calculator for me, or you can do it by hand. Leave it. So that will be 15, and this is 7. So 15 into 7, that will 5 sevens are 35. 3, 7 ones are 7, 8, 9, 10. So that is 105, or that will be 105 00 meter. That's a pretty great distance. Okay, 10500 meter. Okay, this is the answer. Okay, chalo. Next, this is easy. This one is easy. It is easy. This is also easy. Is, I will say it as easy plus, not conventional, because they have given the different unit. Otherwise, it is easy. Okay, 2 part A. Complete the following nuclear changes. Okay, so 238 P92, it is giving out Q plus 4He2. There is a alpha has gone out. So if alpha has gone out, this one will be 90 and this one will be 238 minus 4, that is 234. Now from here they are saying a R and a beta has gone out. So this will be 91, this will remain 234. Okay, number 2. This is easy questions are coming now. I hope you have done this one perfectly. Name the nuclear radiation which has the highest ionizing power. Okay, alpha particles have highest ionizing power. Okay, ionizing power. Okay, next, this is easy. This one is also, these are easy portions, you can always do that. Okay, we are able to see the TV channels clearly when we set TV on auto tuning. Okay, which phenomena led to the clear visibility of channels due to auto tuning? Now this one I hope a lot of you may not be able to do. This is in your book, I don't remember. No, this is not in your book, but okay, I think Selena does not have it, but I'll give you the answer. So what happens is that when you give auto tune, the frequency of the receiver, that is your TV, keeps on changing. Okay, so the TV changes its natural frequency to a different frequency. Now when a signal is coming, the signal has a certain frequency. When the frequency of the TV matches with the frequency of the signal, then a resonance occurs and there is a jump in amplitude. So you will be able to view that channel. So which phenomena led to the clear visibility of channel due to auto tuning? You will write it as the resonance between the natural frequency of TV receiver at that moment to the incoming signal frequency, okay, leads to the visibility of the channels. So this is your answer. Define the above phenomena. So if you are told to define You can say it in this way, that suppose this is your antenna and it will be connected to a circuit or TV tuned circuit. It will be a general RLC circuit. This is the R, this is the L, this is a C. You won't study it in your class, it's not in your class. Okay, don't get worried about this thing. It's a pretty high level question for you guys, but the basic principle you know. So when it will enter and this will match with the incoming frequency, then a resonance will occur. When a resonance will occur, you will get a clear visibility of that channel. Okay, don't get worried. Okay, it's actually not directly in your book, or it's not directly in the ICSE books, uh, but it has a concept related to that in the resonance chapter. So we can say it's in syllabus, but it is a pretty tough question for most of you. Okay, okay, give any one more example of the resonance. You can give any example of resonance, any example of resonance that you may like. Okay, any example of resonance you give. Suppose a man is walking a bridge, or the sudden increase in the loudness of sound when filling of water. You can give anyone. Okay, I will say this one as a hard question because it's not directly. It's actually easy question for a class 12 guy, but for a class 12 student. But for you, as you are in class 10 and you have not directly studied in your course, so directly I will say it is pretty high level for you. Okay, okay. Let us go to question number 8. Define specific resistance. We all know what is specific resistance. That is resistivity. Rho is specific resistance. Define that. Okay, next is um, okay, what happens to the specific resistance of a conductor if its length is double? Resistivity is independent of length, so no change occurs. So no change occurs. Okay, sorry, so no change occurs. This is B and this is C, so no change occurs. Next is C. C is saying that name a substance whose specific resistance remains almost unchanged with the increase in temperature. Okay, name a substance whose specific resistance remains almost unchanged with the increase in temperature. Okay, this one I have to see. Wait. Name a substance whose specific resistance remains almost unchanged with an increase in temperature. This will be manganese. Manganese. Acha, two materials which are widely used in resistances are manganese and constantine. Okay, for manganese, it does not change so much with temperature. Okay, so this one is a easy question, this one is a easy question, but this one I will say it as easy plus question. Okay, generally this does not come. Okay, which nuclear radiation will travel undeviated in an electric field? Always we know it's gamma. How can one stop the radiations escaping from a nuclear reactor in a nuclear power plant? Okay, so this is an interesting question. You don't have the structure of nuclear power plant, but you have the basics of that. So based on that, a nuclear reactor is kept in a housing. Okay, this is known as the containment structure. Containment structure of nuclear power plant. This is the containment structure of nuclear power plant. Now it is made up of three things mostly. One is reinforced steel, that is basically steel. Second is concrete. Now concrete can be 5 to 30 meter in thickness. Okay, 5 to 30 meter in thickness. That 5 to 18 meter in thickness, sorry, 5 to 18 meter in thickness usually. And they can also be made up of lead. PB stands for lead. They can also be made up of lead. So why do they do that? They do that because in case of any leakage, so that the nuclear particles, that is the alpha, beta and gamma radiations, they don't escape out from this nuclear reactor. Okay, that is why it is known as containment structure. So this is how they stop the radiations from escaping from a nuclear reactor in a nuclear power plant. Okay, and if as most of you I think don't have the idea regarding this, I will suggest you that if you write the story of control rods and moderator. If you write the story of control rods and moderator, then also I think that you will be getting the marks, because they also absorb the neutrons, or they don't allow them to multiply. uh, so that can also be answer, a part of the answer. I think if you write this one, the invigilator, the paper checker can also give you number, but this is the actual answer. Okay. Okay, next is C. Name one internal radiation source of background radiation, that is potassium. Potassium. Okay. Find the value of current I drawn from the cell. This is easy question. So I will say this one is easy. This one I will say medium, because it's not directly in your syllabus. But it's there. It's not directly, but it's there. Okay. See, then we will go to 3. So 3. This is the circuit. So this is 3 ohm. This is 15 ohm. This is also 15 ohm. Sorry, this is 30 ohm. And they have said this is 2 ohm and 3.4 volt. Okay, let us redraw it. If we redraw it, the circuit will be, this is the internal resistance, which is 2 ohm, and it is getting divided into two portions. The upper portion has 215 ohm, the bottom portion has a 30 ohm. So I will draw it in this way. Then I will connect it to the battery, which is a 3.4 volt battery. So equivalent resistance in this case will be 30 ohm. So this will be 30 ohm. So the structure will come down to, this is 2 ohm, and this one is 30, the bottom one is 30. So this is 30, this is 30, this is 3.4 volt. Again this one is in parallel, so 30 and 30 will come out to 15 ohm. So that will be 2 ohm. This one will be 15. We know that 1 by r parallel equals to 1 by r1 plus 1 by r2. So in this case, that is 1 by 30 plus 1 by 30. That will be 1 by 15. This is 1 by r parallel, or r parallel will be 15 ohm. So this is that 15 ohm, and this is 2 ohm. This is 3.4. Okay, so that is, so that will be 15 plus 2, 17 ohm, and this is 3.4 volt. Okay, now we need to find out the current in the circuit. We know V equals IR, or I will be V by R. V is 3.4 volt, R is 17 ohm. So this will be 10 down here, this will be 2 by 10, that is 0.2 ampere. This is the answer. Okay, calculate the current, calculate the terminal volts. Now what is terminal voltage? We know that epsilon equals to V minus I, V plus I into smaller. Okay, so V will be epsilon minus I into smaller. Epsilon is 3.4, I is 0.2, smaller is 2. So that will be 3.4 minus 0.4, that will be 3 volt. So terminal voltage is 3 volt. This is a pretty easy question. Okay, it's a pretty easy question. Now let us go to question number 9. I hope 9 is the last question. Question number 9. Okay, 9.1. Calculate the total amount of heat required to melt 200 gram of ice at 0 degree centigrade to water at 100 degree centigrade. Okay. Okay. So what they have told is that, that you have ice which is at 0 degree centigrade. Okay. Now you need to convert it into water at 100 degrees. So first you will convert it to 0 degree. This is ice. You will convert it to 0 degree water. Okay. Now from 0 degree water, you will convert it to 100 degree centigrade water. So at this change, you get a state change. Here you get a temperature change. Now if I write the formula as Q1, you can write Q1 equals to MC Okay, see, it's a state change, so you will write it as m into L of fusion. Q2 you will write as mass into heat capacity of water into temperature change. Okay, so total heat will be Q1 plus Q2. Now let us do one by one. So that is m into LF plus mc delta T. So we will take the mass as common. LF is 336 joule per gram, and C into delta T. C is 4.2, delta T is 100 minus 0, that will be 100. So that mass is given as 200 gram. So 200 into 336 plus 420, right? So that will be 200, and that will be 0, that will be 6, 2 and 3, that will be 5, 4 and 3, that will be 7, 756 into 200. So that will be 756 twice, that will be 1512, I think 151200 uh joule. This is the answer. Okay, 151200 joule, because that is for 200 gram. Yeah, 1500 joule. Okay, you can check the calculation. If it's wrong, you can tell me. Okay, next, okay, let me do the calculation for you. Okay, that will be 756, 756 times 200. Just wait, 756 times 200, that is 1512. Yeah, that's right. And let me again check that one. 336 plus 420, that will be 7. Yeah, it's right. Okay, the answer is right. Now next question they have asked, this is easy, I will say it's very easy. Okay, state the principle of calorimetry. You know the principle of calorimetry, which is the amount of heat lost by hot body is equal to the amount of heat gained by the cold body. Okay, it's easy. Principle of calorimetry is amount of heat lost by the hot body is equal to the amount of heat gained by the cold body. Okay. Name the material used for making a calorimeter. Obviously, we will use a material which is having a pretty less specific heat capacity. A good example of that is copper. Okay, C. Write one characteristic property of the material chosen for making a. I just told you now, that is low specific heat capacity. It's an easy question. This one is also an easy question. This one is an easy question. This one is an easy question. Okay. These are pretty easy questions. They have given one after the other. Okay. Now number 3. Let us get into number 3. Okay. What is number 3 saying? The diagram below shows a cardboard on which iron fillings are kept. A wire is bent in the form of a loop is seen passing through the cardboard. Okay. When current flows through it, the iron fillings arrange themselves as shown. Okay, these are the order of the iron fillings. Okay. State the polarities of the battery and B. Okay. See, here the current is going in such a direction such that the loops are formed clockwise. So if we put our thumb in the direction of current and enclose our fingers, then we get the direction of magnetic field. That means the current must be passing in this direction. Okay. So this is the cardboard. So if this is the loop, then the current is passing in this direction, because of which we are getting loops like this here. And similarly, as it is going down, we are getting loops like this here. Okay. So if current is flowing like this, then it must be having a positive terminal here and a negative terminal here. So A will be positive terminal of the battery, B will be negative terminal. So A will be the anode, B will be the cathode. Okay. Okay. Next, State the effect on the magnetic field if an iron rod is held along the axis of the coil. So this is the coil. If we put an iron rod here, what will happen? Observe it carefully. So this is the direction of magnetic field for the loop, this one, loop A. Let me write it as loop, not A, let me write it as loop P. And for loop Q, this is the direction of magnetic field. That means if I place a rod in here, the rod will get a magnetic field, a induced magnetism, such that the magnetic field vectors will align in this direction. That means this will be the north side, this will be the south side. Okay, in this way it will align. So that will be the north pole, this one will be the south pole. Okay, so it will get a north pole here, it will get a south pole here. Okay. Okay, now stay one way to change the polarity of the coil. Change the polarity of the coil. Yeah, we can change the polarity of the coil by changing the direction of the battery. So that is a possibility. So changing the direction of battery. Okay, battery direction, this is possible. Next, decrease the strength of the magnetic field around the coil. So we can decrease the strength of the magnetic field in two ways. They have asked one way, but we will give two ways. One is if we decrease the number of turns. First is decreasing the number of turns. This is a possibility. And second is increasing the radius of the loop. Increasing the radius of the loop. Okay, these are the two ways. So I will mark it as a easy one. This is a easy one. This is a easy one. This is also a easy one. This is of course a easy one. Sorry, easy. Easy will be E. Okay. So we get the answers. Now I have completed the entire portion. If you find that you are having any doubt in any of the solutions, or if you find that I have done some miscalculations, or I have misread the question and I have not answered that properly, feel free to let me know. The number given there is my number. You can call me also. I don't know whether I'll be available on call so much, but this is your answer key for 2023 physics ICSE class 10. So wish you best of luck and best wishes for your final results. I know that you will be doing good. This is just so that you can verify your answers. Okay, stay happy. Bye bye.